Hey, good morning, everybody, and this is Mr. Ainsworth. And we're going to get into our last lesson here in Chapter 10 here in Modern Math or Discrete Math and talk about how to add up terms in a geometric sequence. Okay, we call them geometric sums or geometric sum of series, okay, where you take a geometric series or a geometric series, which is a sum of a bunch of geometric terms, and add them up. How do you do that? Like, how do you add up the first 5 terms or the first 10 terms or the first 1,000 terms in a geometric sequence? How do you do that? So let's go through it. There's a couple different general formulas, but I'm going to go over one in particular that we can apply to everything here. So suppose the sum, and we're going to use capital S for sum, all right? The sum of the first n consecutive terms, that's an important part right there, of this geometric series is the following, okay? Where the first term here is a, you multiply a times r, the common ratio here, you get a times r, so times r right here. Multiply it times r again in any geometric series or sequence. You get r times r will give you a times r squared, and then you multiply it by r again, and r squared times r gives you r cubed, so you get a times r cubed. So this is the first term, second term, third term, fourth term. This is the fifth term, and so on. You keep multiplying by the common ratio here, and you get the sum of many terms of this geometric sequence. Okay, it looks a little bit complicated in this form, but this is technically how it's written. So what we're going to do is we're going to simplify it just a little bit here. We're going to call our first term here, we're simply going to call it A1, okay? Right here, this represents our first term. Our second term, which is a times r, whatever that number is, we'll call that the second term. We're going to simplify that. We're going to call it a2. Our third term, which we call a times r squared because we had to multiply by r twice here, we're going to call that, well, look at this, a3 and so on. And then we get a4 and we get all the way to the nth term right here. So this is your nth term. So I'm going to simplify this expression here, or this sum, this geometric sum, to a1 plus a2 plus a3 plus a4 plus a sub n. Okay, so there's actually n terms right here. N terms, and that's important because the sum depends on the first term. This is your first term. It depends on the geometric or the common ratio, and also depends on how many terms you're adding. That's it. It doesn't depend on the last, which is kind of nice. In arithmetic series, they did. It depended on the first and the last. Okay, but the geometric sum only depends on r, the common ratio. R equals common ratio, or the growth rate, depending on what problems we're dealing with here. And it deals upon the first term here and how many terms you're adding. And the sum, which I'm going to call S, S stands for sum now, is going to be equal to the first term, A1, times the quantity 1 minus, excuse me, let me write it correctly here, 1, 1 minus r to the nth power, all right, divided by 1 minus r. All right, so we need to get used to inputting this formula into our calculator here. Remember, A1 represents your first term. R stands for your common ratio. All right, N stands for the number of terms. Okay, you are summing, that is. So it's a pretty simple formula because all you need to know is the first term, the common ratio, and the number of terms. All right, so this is our main formula that we're going to be using in the entire lesson here. And the only thing we need to do is get some experience, get some practice. Okay, so let me go over a variety of different examples here. So we need to find the following sums. Okay, notice that sums, this is the key word of the geometric sequences. All right, so the first thing I know is that A1 is 8. I do know that. That's simple. A1 equals 8. This is your A1. There's 1, 2, 3, 4, 5, 6 terms we're adding. So n equals 6. There's 6 terms. The other thing I need to know is the common ratio, okay? And the common ratio, well, we know that from the prior lesson, right? We take the second term divided by the first term. So 12 divided by 8. Let's get your calculator going too because we're going to be using it quite a lot here. All right, 8 divides into 12 one time with 4 remaining, so it's 1 4/8 or 1.5. So if we take your calculator and if I take 12 divided by 8, I should get 1.5. So the common ratio is 1.5 or 1.5. So my sum for this one here, my sum should be equal to the first term, 8, times the quantity, 1 minus 1.5 to the 6th power, divided by 1 minus 1.5. Okay, so the question is, what is that? So let's do that, okay? All right. Now you got to be careful how you do this because the quantities here inside this fraction here should be in surrounded by parentheses right here. So you got the quantity of 1 minus 1.5 to the 6th power, whatever that is, divided by the quantity 1 minus 1.5, and then you got to take that result and multiply by 8. So 1, let's start off with quantity here. So the quantity of 1 minus, come on calculator here, there we go. Okay, so 1 minus 1.5 raised to the 6th power. There we go. Get out of the exponent, close it off. All right, divided by quantity 1 minus 1.5. Okay, I get 20.78. So we're not done yet. We're going to multiply this result times 8. So we go times 8, and we get 166.25, which is the total sum of these terms here. So you get 166.25. And you can check by adding the terms, okay? Check by adding all 6 terms. That's an easy thing you could do. Just simply input this in your calculator. You got to take 6 plus 12 plus 18, as long as you type it in correctly here, plus 27 plus 40.5 plus 60.75. And we should get the same result if you enter it incorrectly. So 16, 12, 18, 27, 40.5, 60.75. What did I do incorrectly here? So 18, 27, 40.5, 60.75. What did I do incorrectly here? So, oh, I put 6 plus 12. I was supposed to put 8 plus 12, so I got to add 2 more. Okay, so there we go. And notice they're the same now. Okay, my first number should have been 8, not 6. So inputting the correct numbers in the calculator is important. Okay, calculators are nice, but you got to input the numbers correctly. All right, and there's number 2, or number 1. Number 2, find the sum. All right, find the sum of the first 10 terms. So n equals 10. So n equals 10 of a geometric sequence. The first term is 1. Ooh, okay, so a1 is 1. First term is 1 right there, and the common ratio is 2. So look at this. They gave us all the information we need. So the sum is equal to a1, which is 1, times 1 minus 2 to the 10th, divided by 1 minus 2. So the question is, what is that? All right, so let's clear it out, and let's put the numbers in correctly this time. So 1 minus 2 to the 10th. Okay, there's my numerator. All right, 1 minus 2 is -1, so divided by -1. Do a little mental math, I get 1,023. And then times 1. So this one's very straightforward. You get 1,023. Easy. All right, so you could check that too, by the way. The sequence, if you want to generate it, all right, you start off with 1, and then the common ratio is 2, so you double it 10 times. So 2, 4, 8. Well, I got to add these right here. This is a series, so you got to sum the terms. So plus 2, keep doubling, 4, 8, 16, right? 32, 64, 128, 256, 1, 2, 3, 4, 5, 6, 7, 8, 9. One more time, plus 512. If you add up all these, you get the same thing. You get 1,023, and you could check. Okay, so check by listing out the numbers and adding them up the long way. Okay, all right, next problem, number 3. Let's get some more experience here. Number 3. So the first term here is 4, so a1 is 4. All right, from 4 to 4 times 0.3, obviously it's being multiplied by 0.3, so the geometric ratio right here is 0.3, or 3/10. So r is equal to 3/10. Let me see, how many terms are there? So check this out. This is the first power here, second power, all the way up to the 11th power. So right here, I see 11 terms. Now, if you add in this one here, the first one here, there's your A1 right there. 11 plus 1 is 12 terms. So n equals 12 terms. All right, just look at the powers. From the first power to the 11th power, that's obviously 11 terms, right? Plus the first term, well, 11 plus 1 is 12. 12 terms. So the sum is going to be equal to my first term, 4 times 1 minus r, 0.3 to the 12th power, divided by 1 minus 0.3. So what's the sum? S stands for sum. So let's figure that out. So we go 1 minus 0.3 to the 12th. I'm going to step it out, do it step-by-step approach. Divided by quantity, 1 minus 0.3. 1 minus 0.3. And I get this decimal here, 1.428. And then I got to multiply it by 4, so times 4. And I get 5.714 rounded. Okay, let's round it to the nearest thousands. So 5.714. And that's how the game is played. You just have to know how to set it up, and then you have to know how to use your technology properly. Okay, on number 4, we got the first term is 5. So A1 is 5. We want to go first 8 terms, so n equals 8. The common ratio from 5 to 15, so r is equal to 15 divided by 5, which is obviously 3. You got to multiply times 3 here, times 3, and so on. So that's r. That's a time symbol here. Okay. So what do we have? So the sum is equal to the first term, which is 5, times 1 minus the common ratio to the nth power, divided by 1 minus the common ratio, which is 3. So what's the sum? So here we go. After we set it up, we go for it, okay? So 1 minus 3 to the 8th. All right, there we go. It's a big number. You know, you multiply 3 8 times, you get a big number. And then if you subtract it from 1, you get a negative number. Divided by negative 2. 1 minus 3 is negative 2, so don't enter it in. Just do it in your head, right? And you get 3,280 times 5. You got to multiply it times 5 right here. Oh, I didn't mean to hit the button twice. I get 16,400. Okay? And that's how it is played. It's not too hard. Let's try it again, okay? Here we go. First term is 10. So A1 is 10. Common ratio from 10 to 10 times 2.7. The common ratio is 2.7 here. Times 2.7. That's the common ratio right there. A times A, the first term is A, and the other one's A times R, right? So R has to be 2.7. So the common ratio is 2.7. Okay, there's 8 terms here, plus 1 more the first term, so there's 9 terms total. So n equals 9 terms. So the sum is equal to the first term, 10, times 1 minus 2.7 to the 9th power, all right, divided by 1 minus 2.7. So what would that give us? Let's clear it out so you can see things better here. So 1 minus 2.7, all right, raised to the 9th power. I'm going to do a step-by-step approach, but no parentheses. All right, divided by 1 minus 2.7, which is negative 1.7. So divided by, if you want to enter it in, you go quantity, 1 minus 2.7, or you can just think about it in your head. That's negative 1.7. And you should get a positive result because the denominator is negative. And then you got to multiply it by 10, so times 10. And we get 44,850.57 roughly. So 444,850 point, let's say 57, rounded to the nearest hundredth. Okay? All right, last one here on this side here. So the common ratio R is 0.75. Initial population is 4,500, so A1 is 4,500. find the sum of the first 23 terms. So n equals 23. Got to write it down correctly. Okay, and now we go for it. So the sum equals 4,500 times 1 minus 0.75 to the 23rd power divided by 1 minus 0.75. All right, let's see what we get. All right, so let's go 1 minus 0.75 to the 23rd power. Press enter. Divided by quantity 1 minus 0.75. Let's give us 3.99, and then we got to multiply by 4,500, so times 4,500. And you get about 17,975. 17,975.91. Let me check that. All right, looking at 0.92. Okay, so rounded to the nearest hundredth. Okay, now let's apply it to an application problem here, and then I'll have you guys practice afterwards. On example 3, imagine there's an infectious disease called the X virus, with no known cure. The first appearance of the X virus occurred in 2005. So occurred in 2005, the first one here, year 0, when there's a total of 5,000 cases were reported. All right, so let's set up a little table here. So year here and number of cases here. So we start off in 2005, and there's 5,000 cases reported. The virus will spread at an annual rate of growth of 40%. This is obviously important. Okay, so knowing this right here, it will increase. It will spread at, let me see, 40% annual growth. That means that the following year I'll have 140% of what I started with. All right, so R here is going to be 100%, 100% plus the 40% because there's 40% rate of growth, which is 140% obviously, which as a decimal is 1.4. So this is the growth rate. Just by looking at this number here. The question is, how many cases will there be of the X virus over the 10-year period? All right, total. That means sum. We have to add up the cases in every single year from 2005 to 2014. So let's generate a sequence so you can see things a little bit better. Okay. So this first one here, in 2006, we have since the growth rate. Oops, 2006. All right. Come on, Ainsworth. There we go. All right, the growth rate, since the growth is 140% or 1.4, we got to multiply this by 1.4 to get to see how many reported cases there in 2006. Because again, this thing has no known cure, right? So it's going to increase over time. So we're going to take 5,000 here. I'm just going to generate a couple years so you can see what's going on. We're going to take 5,000 and we're going to multiply it by the growth rate 1.4, and I get 7,000. So there's 7,000 cases in 2006. In 2007, I got to multiply that times 1.4 again. So that's easy. All right, so times 1.4, and I get 9,800. So in 2007, there's 9,800 cases reported. All right, the question is, what is there in 2014? Because I'm not going to list them all. How many is there? And so what we need to do is use our explicit function to figure out what that is. We know the common ratio here is 1.4. We know the first term is 5,000. So let me see here. Let me write this out in red here. So P sub n for any geometric series is always the first or initial population times r to the nth power. All right, so what we're going to do is we're going to take our P sub 0, this is your P sub 0 here, which is 5,000. So we take 5,000 times 1.4 to the, let me see how many years have expired from here to here. See, this is after 1 year, after 2 years, all the way to 2014. That's after 9 years. All right, so from here to here, all right, 9 years. 5 plus 9 is 14, right? So we got to take it to the ninth power here. So what is that? Let's figure that out too. All right, so 5,000 times 1.4 raised to the ninth power. That's 10,000, excuse me, 103,305. So 103,305 roughly cases. So it grows. I mean, in over the 10-year period, there's 10-year here over the 10 years here. There's actually this is a 10-year period, okay? Because we're starting counting from 2005 all the way to 2014. All right, over this 10-year period here, there's going to be a lot of cases, and what we want to do is find out how many estimated cases will be total over the 10-year period. Okay, so there's actually 10 years. If you list them all out, there's 10 of them, okay? From 2005 to 2014, list them out. There's a 10-year period. 10-year period. So if we add up 5,000 plus 7,000, the sum of the cases here, we add up 5,000 plus 7,000 plus 9,800 plus all the way to this number here, which is the last one right here in the 10th year. You know, how many would this be? So here we go. We got A1 here. A1 is 5,000 here, so the total sum should be equal to 5,000 times 1 minus the common ratio, which is 1.4. There's your growth rate. Over the 10-year period, so to the 10th power, divided by 1 minus 1.4. So what would that total sum of the cases be? And it's going to be a large number, because if you add up all these numbers, I mean, it's going to be big, right? So we take 1 minus 1.4 raised to the 10th power, all right, divided by 1 minus 1.4. And then I have to multiply it by 5,000. So times 5,000. There we go. And we get a large number here. We get 349,068 cases. Okay, 0.31. So, all right, but remember, these are people, right? So we got to round it. So it's approximately equal to 349,068 cases total, okay, over the 10-year period. All right, and that's how you apply it, guys. So this section here is a little bit different, because you're not just finding the nth term, you're finding the sum of all the terms. All right, which is found by adding all the terms up, okay, by using the formula that we generated. So what I want you guys to do is get some practice. So here we go. Right here is a little practice set here, and what I want you guys to do is just turn the page, because I have them all right here. This is where your homework is. It's from the book, but I just copied it off and put it in your notes. Go ahead and work on these. Do your check your work with my answers when I send them out, and I'll see you in my review lesson at the end of the chapter. I'll see you. This is Ainsworth. Bye-bye.